Today we are going to understand analog to digital converters by solving a question. A speech signal with a maximum frequency of 6 kHz is to be converted into digital form for an online system. And we are going to use an ADC, analog to digital converter, with a voltage range of -2 volts to +2 volts and a 12-bit resolution. Okay, so we know that a sound is a wave, and a wave is an analog signal. So how do we convert this to digital signal? So we are going to take samples at some discrete points. So let's assume we sample this point, this point, this point, and this point. So how often you take these samples is what we call the sampling rate, or the sampling frequency. So we'll mark particular points. So at this particular time, we took a sample of where the voltage is. So we take samples of these points. So the more your sample rate, the better the quality of your sound. So we are trying to track this particular curve using discrete values. Okay, and aside that too, the volts, let's say, so we know here is +2 volts and -2 volts. So the bit resolution also counts, because for 1 bit resolution we are going to have only 2 levels. So the 2 levels, so we know, so wherever, if we get 1 volt lies somewhere here, but since we only have 2 levels, we are still going to represent it with a 0 or a 1. This is 2, so it's going to be 1. It's closer to 2 than to the -2. So high and low, 0, 1. So if it's 1, we are going to make it 2, and if it's maybe -1 will be somewhere here, but since our levels are only 2, it's automatically -2. So that one too has an effect. Yes, so let's start solving some questions. So let's calculate the minimum sampling rate. So our minimum sampling rate, first let's calculate for our sampling rate. So we'll use the Nyquist theorem, which states that our sampling frequency, or the sampling rate, is greater than or equal to twice the maximum frequency. So Nyquist said that our sampling rate should be should be greater than or equal to twice our maximum frequency. As per the question, they stated that our signal has a maximum frequency of 6 kHz. So we are going to solve it. So we know that f of s, sampling frequency, should be greater than or equal to twice our f max. The maximum frequency was 6 kHz. So we are going to get 2 times 6, which is 12 kHz. Okay, now after getting this, let's find the minimum sampling rate. So the minimum sampling rate is equal to 12 volts. Sorry, it's 12 kHz, because we said our sampling rate should be greater than or equal to. So if the minimum one is the equal to, so that's why our minimum sampling rate is 12 kHz. Okay, so let's determine the number of quantization levels. So in determining the number of quantization levels, let's denote that as L. The formula is is equal to 2 exponents the number of bits or the bit depth. So our number of quantization levels is equal to, so L is equal to 2 exponents n, where n is 12 as per our question. 12 bit resolution, that's the bit depth or the number of bits, so exponent 12, which will give you 4096. Let's calculate for the C. We are going to calculate the quantization step size. So quantization usually denoted by delta. So our quantization step size is given by the maximum voltage minus the minimum voltage all over our number of quantization levels. So that is L. Yeah, so we already calculate for L and we got 4096. So I'm just going to put it in the equation. So our max voltage as per the question is positive 2 volts and the minimum is negative 2 volts. So positive 2 minus negative 2 volts all over 4096. So we are going to get 2 plus 2 again 4, so 4 over 4096, which will end up giving us 9766 volts. Okay, so now let's find the maximum quantization error. So D, our quantization error is given by the quantization step size all over 2, so half of it, and it's a plus or minus. So quantization step size all over 2. So we got 0.000976 as our quantization step size. We're going to divide it by 2, so we have plus or minus, which will give us 0.000483 volts, plus or minus. And to find the maximum, we are going to take the positive value, so that will be 0.000483 volts. Yes, so this will be our answer. Okay, now let's find the bit rate. Assuming that it's a stereo, it's a stereo system. So stereo has 2 channels, so that is stereo. Stereo has 2 channels, left, right. Okay, so our bit rate is given by our sampling frequency times the bit depth times the number of channels. So we are going to have, so we had 1200, sorry, 12 kilohertz as our sampling frequency. Let's multiply it by our bit depth times the number of channels. So it was stereo, so it's 2. So we are going to get 288,000, and bit rate is in bits per second. So now we get 288 kilobits per second. So that is all for today.
Travailler c'est bien, bien mieux qu'être mal accompagné, pas vrai? Où est ton papa?